Hey everyone, so I wanted to make a quick video just sort of talking about using the distribution of a discrete random variable. This example is from the bottom right corner of page 365 in your textbook. If you have an online textbook and you're using that, it's middle of section 6.1. And so here we have this example where we have grades for online classes, and we see 0 is going to correspond to an F, a 1 is going to correspond to a D, a 2 is going to correspond to a C, a 3 is going to correspond to a B, and a 4 is going to correspond to an A. Now you could have done this in complete reverse, but you just have to sort of pick what these letters are going to correspond to in numbers, because remember, and by remember, maybe know for the first time, a random variable is a technical term, and it takes on a number. So random variables have to take on numbers because we're going to be able to do things like find averages and find standard deviations and find variances, and therefore it needs to be a number. Okay, so we're just trying to translate away from the idea of like probability of an A, and we're going to call that the probability of getting a value of 4. Okay, so all the logic is pretty much the same, but we want to use numbers. So one question you might see, or so that we have to talk about the situation, the scenario, is you are going to select a student at random. So select a student at random, and these these data up here, the distribution is showing the grade distribution for online courses at a university. According to the textbook, it's the University of Indiana at Bloomington, but it's the online course, so it's at nowhere, I guess. So select a student at random. And you'll notice one of the values is missing, and so that's the first question, is what is the probability of 2, which is another way of saying the probability of getting a C. And what we know is that all 5 of these probabilities down here must add up to 1, because all you can get is an A, B, C, D, or F. And so we know that these need to add up to 1, and so we would say the probability of 2 is just whatever 1 minus all of the numbers that we do know are. So 1 minus 0.457, minus 0.362, minus 0.032, minus 0.011, because we need these all to add up to 1, and so the one that's missing has got to be 1 minus all the ones that aren't missing. I apologize if I'm spelling that out too slowly. So I'll pause it for a second and do that calculation by hand, and we get a value of 0.138. 0.138, and we can plug that in right there. So 0.138. And the nice thing about values like this is we can answer a lot of different questions, so including ones that sort of have these complex ideas in them. And you'll see one of the questions that is asked is, what is the probability that x, our random variable x, is greater than or equal to 3, which means when we take an observation of this scenario, selecting a student at random, what's the probability that the grade is a 3 or higher? Now, what on earth is a 3? Luckily, we've got our little cheat sheet over here. A 3 is a B. So what this is saying is the probability that the person gets a B or an A. So probability of A, B, or A. If you want to phrase that higher, a B or better, or you could phrase it as at least a B, or you could even phrase it as better than a C. There's lots of ways you could phrase that, but I think a probability of a B or an A gets the idea across. And I think one thing, just that using that as an example, is that there's going to be situations where you're going to phrase it one way, your friend is going to phrase it another way, and you just want to be clear that they might mean the same thing functionally. And so, we'll just try to be as clear about what we mean as possible every single time. So we look, and where are the situations where you have a 3 or greater? It's those two. Awesome. So we're just going to say this is the probability of getting a 3 plus the probability of getting a 4. And we can do this because it is a discrete random variable. If this was not discrete, we'd have to consider what about a 3.2 and a 3.3, and heck, what about even between those 3.321 or 3.3222 or something like that. There's all kinds of craziness that can go on with a continuous variable. But luckily, we're going to avoid that at the moment. We'll get back to it later. For now, because it's discrete, we just look at all the ones that are at least 3, and we see that there's 2 of them, and so it's going to be 0.362 plus 0.457. And you'll notice I didn't have to subtract the probability of 3 and 4. I suppose I could, but it's impossible for a randomly selected student in one class to get both a B and an A. So these things are mutually exclusive. I'll write this in here, minus the probability of 3 and 4. But that's just minus 0. And I'll write because 3 and 4 are, and I like the word disjoint because it's shorter than mutually exclusive, but it means the same thing. And it's a little more technical. So we get these 2 values, we add them up, and we notice that's going to be 0.819. And so we see about 82% or 81.9% of the students get a B or an A. And now we also are being asked in this problem to make a histogram of the data. And you guys have made histograms before. And so let's just do that over here. We notice the values that it can take on are 0, 1, 2, 3, and 4. So we have to sort of have those shown. And I think one of the things that's really going to be important is you have these bins, and we need 5 of them, 0, 1, 2, 3, and 4. This is 1, 2, 3, 4. We need another one. But when you go to label them, the labels are in the middle. So it's 0, 1, 2, 3, and 4, not at the intervals. You don't put the 0 right there. You put it in the middle because this is the idea of all the people that got a 0, all the people that got a 1, all the people that got a 2. I've certainly seen situations where textbooks will just draw a straight line up, and there's a reason for that. But your textbook does a histogram with bars, so we're gonna stick with that. And so let's have the histogram go up, and we'll do the probability of x. So here we've got x, here we've got probability of x, and it can take on these various values. And so 1, it's with about 0.01, so it's going to be super low. We need to get all the way up to like 0.457, so we'll do like 0.5 here, which will put us at 0.4, 0.3, 0.2, 0.1. That's pretty good. 0.1. And so 0.01 is crazy low. It's, down here, something like that. 0.032 is also really low, but a little bit higher. Something like that. The probability of 2 is 0.138, so considerably higher. Maybe like that. I'll erase a little bit. Probability of 3 is 0.362. And so that looks like it's probably about here. And because it's a histogram, these should all connect. And the nice thing is, lastly, it's 0.457, so that's the highest. We can see here that the data is definitely skewed left, which is always confusing because most of the data is on the right, but the skew is where the tail is, and the tail is to the left. And so that's going to mean that the mean is lower than the median. And we're going to figure out we're going to talk about the mean in a second in another video. The median is, of course, you're kind of looking and seeing where they add up to 0.5. And, if you did 0.011, so here plus here plus here, you're still not even close to 0.5. Add this, now you have eclipsed 0.5. So the median is somewhere in the B range. And so you could answer things like that. So the median is going to be equal to 3, since we're saying it's just 0, 1, 2, 3, or 4. So the median is going to be a B. The mean is going to be a little lower. It's going to be pulled down. And we'll sort of see how that goes exactly. But the median has to be an integer here, because you can only take on 5 different numbers, and they're all integers: 0, 1, 2, 3, and 4. And I think that's about all we got. Certainly unimodal, skewed left, as I said before, very much not symmetric. And I think we're good. The range is, of course, 0 to 4. That's a bit trivially obvious, but there you go. And yeah, there's an example with a discrete random variable. Not actually calculating anything really just yet, but just noticing some aspects of it. We could, of course, kind of go to other questions like this one. We could ask, what is the probability that x is less than or equal to 2? And you would just look to your data and you would say, oh, well, there's 3 values that are less than or equal to 2. It's 0, 1, and 2 right up here. And those have those probabilities, and you would just add 0.011 plus 0.032 plus 0.138, add them up. And it's nice and obvious. I don't think there's not really a trick there. There's plenty of tricky things coming in the future, but not with that one. Okay, so I hope this helps, and I just got an email. You can hear it. All right, thanks so much.